Hello friends, Satyendra here, and in this video, let's design rotary slider mechanism using top-down assembly approach in Creo Parametric. So let's get started. So here I will design the whole assembly using top-down assembly approach. So I'm not having any drawing for this. And once we complete the assembly design, we will design this rotary slider mechanism. But before I start, it is my humble request to all of you to please subscribe my channel first, because 80% of my viewers are non-subscriber. So this is not fair. At least this much you can do for me. So please take some time and subscribe my channel first. Thank you. Now to start this design using top-down assembly approach, first you create a new assembly file. So go to new and assembly, assign the name. So I'll take name as rotary slider mechanism, uncheck use default template, say OK, and select a proper assembly template. So I'll go with this and say OK. So I've created a new assembly file. Now here, to start the assembly design using top-down assembly approach, you need to use this option, create. So we will create all the parts here only. So first you save this file and then you go for create. Now when you create a new part within the assembly, you will get this dialog box. Now from here you can create part, sub-assembly, skeleton model, bulk item and envelope. These are different topics here. So we will stick with the part. Here I will take part name as P1. I'll say OK. Now from here you need to select the part template. So this is the right template. You can browse the new template if you want. I'll go with my template and I'll say OK. Once you say OK, you have created a new part. Now you need to assemble that part inside this assembly. So you simply go for default and say OK. Your part is created here. Now you simply click on this part and activate it. Once you are activated, you have your part datum inside the assembly datum, and then you have all the options related to part modeling here. So I am creating the first part, which is the base part, and for that I will go for extrude onto the top datum plane, normal. Now I will create a center rectangle just like this. Dimension, so this one I'll take 150, this I'll take 50, and I'll say OK. Now this thickness I will take it as 15 and I'll say OK. Now the next feature, so once again go to extrude, and this time you just select this back face, normal. Now here once again I will create a rectangle like this. Then I'll create 3-point arc like this. This I will make it construction. Now this I will consider 40. This one I will consider 50. And I'll say OK. Flip the direction and thickness I'll take it as 10. I'll say OK. Next feature, onto this face, normal. Go to reference, select this as a reference and then draw a circle. This die is 5, say OK, and then this length is 10, say OK. Now the next feature is a cut feature. So go to extrude, select this face, normal, and then you draw a rectangle. just like that. Draw a center line somewhere here and then make this rectangle symmetry with this. This value I will take it as 30, then this distance I will take it as 10 and this length is 80. I will say OK. Flip the direction, this is a cut feature, and depth you take it as 2 next and say OK. Similarly, one more extrude cut onto this face. Go for reference and select this face and this face reference, and then you create one more rectangle somewhere here. This dimension take it as 2.5 and then this value you take it as 10. Say OK. Flip the direction and make it to all. Say OK. So this completes my first part. Now once this is over, you just activate your assembly. So now once again you are inside the assembly mode. Now the next part. So once again go to create. Again same procedure, part, take part name as P2. Say OK and OK. Once again assemble it by default and say OK. Now this time you select this part and activate it. Now go for the second part. So I will go for extrude. I will select this face. I will say normal. Now go to reference. Select this reference. Draw the circle just like this and then like this. Now say OK. And this thickness take it as 10 and say OK. Once again go for extrude. Select this face, normal. Go for reference. Select this as a reference. Draw a center line like this and then draw a circle. This you take it as 5. Say OK. This you take it as 10. Say OK. And this completes the second part. Now just say Ctrl A to activate the assembly. So the rotary part is done. Now the third part is the slider part. So for that once again go to create, part, P3, OK. Copy from existing. Same way, just say OK. Assemble it. Say OK. Activate this part. And for this I will go to extrude onto this mid plane, front plane, normal. Here I will go to reference. I will take this as a reference, this as a reference, and this as a reference. I will take this also as a reference. I will draw a center line like this. Then I will draw a circle somewhere here. This gap I will take it as 15. This is 5. Say OK. Go to selected and select this face. Say OK. Next feature onto this face, normal. Go for reference, select this as a reference, draw a center line, and then you draw center rectangle from here, just like this. Say OK. This side you can take 10. Say OK. One more extrude onto this face. Go for reference. Select this circle. Draw a center rectangle from here, just like this. Say OK. And this thickness you take it as 5 or take it as 2. Say OK. Now select these 3 features, go for mirror to this plane, say OK. So the third part is also done. Just say Ctrl A. Now this part you can pattern it. Select the direction pattern. Flip the direction. Take gap as 20. Say OK. Now the fourth part. So once again go to create part P4. OK. OK. And default. Say OK. Activate this part. And then go for extrude, select this face, go for reference, select this and this as a reference. Now draw a circle like this and then a bigger circle. This you take it as 10. And then you draw a line from here till here and then from here till here. Make these two lines equal, so automatically it will become symmetry. Delete segment, this segment and this segment. Now just add the gap between these two. So this again I am taking 5. I say OK. This you take it as 5. Say OK. So this completes the fourth part. Ctrl A. Now select this part and again go for pattern. Go for direction pattern, this direction. Take this as 15. Sorry, 25 and say OK. Now the last part, which is the connecting arm. So for this, once again go to create part P5, assemble it, say OK. Now activate the part and go for extrude, select this face, normal. Now go for reference, select this as a reference and this as a reference. Now draw the circle. So one circle like this, another circle like this. Here also one circle like this. This you take it as 10. Here also this you take it as 10. Now draw a center line from here till here, and then draw the line like this, and like this. Make it symmetry, this and this, symmetry with this. Add the gap, so this I'll take it as 5, and then delete segment, delete this and this and this and this. Say OK. This I'll take as 10. I say OK. Control A. So this complete your assembly. Save it. Now one small change I will do to this part, second part. So just activate it and then go for the second feature. This feature I'll just move it here, this side. So I'm just deleting this reference. I will move this to this one, delete this tangent. I will move this side. I'll take it as 15. I'll say OK. Say OK. Control G. So the arm will automatically update. So this is the advantage of top-down assembly approach. Everything is linked together, so it automatically updates. Save it. Now once this is done, this is completely fixed. You cannot move any part anywhere. Okay. So you cannot play the mechanism. Now to play the assembly mechanism, you need to reassemble these parts using dynamic constraint. So let's do that. And for that, I will recreate one more assembly. Where I will reassemble all these parts. So the design process is done using top-down assembly approach. Now for mechanism, we will go with the bottom-up assembly approach. So go to assemble, call the first part, go for default, say OK. Second part, now you need to assemble it using dynamic constraint. So since this part is a rotary part, for rotary use pin. Now select this face with this face. So you have rotary alignment, then select this face with this and say OK. Now if you play with this part, it will rotate because it is having rotary constraint. Now the third part, so go to this part, open it. Now this part is a sliding part, so go to slider and align this part with this edge to this edge, and then select this bottom face to this face, move it inside and say OK. So now this part will slide inside just like this. Now the next part, which is this one, So this part I will assemble with the normal constraint. So I will simply go with this face to this face, and then this face to this face. Take it coincident and say OK. Now one more time I will repeat this part. So I will call this part, and this part also I will simply assemble it with a normal constraint. So I will go with this face to this, then this face with this, and then the bottom face, which is this face with this, and I'll say OK. So now if you drag this component, both will move. Now this part P4, just pattern it, go for direction pattern, select this direction, flip it, 2 numbers, and this you make it 25. Say OK. Now you drag the component, moving. Now the last part, this one. So this is also a rotary part. So I will go to pin, I will select this face with this, then this face with this. So one side this is done, go for new set, and then you select this face with this. Then this side face with this. Say OK. And your assembly is done. Now just use drag component to see the motion. It is happening. Now to play this mechanism, simply go to application, mechanism. Now for the basic mechanism, there are 3 things we need to keep in our mind. The first thing is the dynamic constraint for moving parts. The second thing is connection, and the third thing is the motor. So here in this assembly, we don't need any connection. We can directly add a motor. So for that, I'll go to motor, and I will add a servo motor to this symbol. This is a center symbol. Now here go to profile details, go for angular velocity, degree per second, and here there are different ways to run the motor. You can run the motor with constant speed, or there are different ways. I go with table because from here I can control the speed for different timings. So I'm taking timings for 1 minute. So 0 to 10 second, 10 to 50, and then 50 to 60. So the 60 seconds. Now speed. So 0 to 10, speed is 0 degree to 90 degree, and then constantly it will run till 50 second, and then again from 50 to 60, 90 degree to 0 degree. And then if you see the graph, you are getting like this. If you change it to spline, it will become smooth motion. Just say OK. Motor is applied. Now go to mechanism analysis, and here you just change to kinematic. Start time is 0 and end time is 60 seconds, which we have added there. Then motor start to end, frame rate is 10. Snapshot, we don't have any snapshot. Just say OK here. Go for drag component, and here you just take a snapshot, close. Then From here you can access the mechanism analysis. 0 second, 0, 60, motor start to end, snapshot. Now you have this snapshot. Now just run this. It is running in opposite direction. Just say OK and go to the motor. Just flip it and say OK. Once again go to the analysis and once again run it. This time it is running in proper direction. OK. Now go to the playback, play it. You can speed up from here, just play it. So it will run for 1 minute. And it will close like this. Now from here you can convert it into video. So you can play with these settings. And this complete the rotary sliding mechanism. And this is first level of design. So there are not much level of details here. So that's it from this video. So this was a rotary sliding mechanism using top-down assembly approach in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.